choosing to acknowledge is the hard part. Okay, I am disappointed in you, which makes me question my whole life because I don't know, you're making me question my whole day tomorrow. So we've got to get it together. First things first, what did we do yesterday?
We finished all our tests.
We finished a test. I'll go a point back to 4 and 5. And then what were you saying at table 2?
We finished 3.4 and then we did 3.4.
Yeah, we finished 2.4 and then we started 3.1 and your group can have a point 2. Okay, so you were supposed to, theoretically. But, Keyshawn, you weren't here yesterday. Hand me your book, please. Keyshawn wasn't here yesterday, so his book is going to be blank. What I'm afraid is going to happen is that people who were here and are just doing what he's doing now and playing on their phones also did not complete what they were supposed to complete yesterday. So as a reminder, there is a new assignment today, but if you have not finished the warm-up question on page 25, you have a problem. That's what you were supposed to have done yesterday. If you didn't do it yesterday, and you're a little behind today, get it done first when I get done rambling. Okay. We're starting a new chapter. It's a new you. So if chapter 2 in logic wasn't your friend, it's no big deal. In fact, if you looked at the title of chapter 3, we're actually on counting. We're on counting. So, and counting sounds nice, except when you deal with really big things. So today we're starting 311, but before we go crazy and I say every group to start 311, let's do a workshop and write a note about sample spaces. Okay, what's really wrong with our workshops? We're super behind. You can have a point for that. That's how far behind we are, as this says 10:2 to 10:6, and it is 10:17. Whoa, behind. It's my own fault, because, I don't know, we got excited doing truth tables and all that jazz, and so it's fine, but we're going to get caught up. So today we're going to do 1 through 4. I'm going to leave 5 through 10 for Thursday. So if you're trying to get your group some points because you would like to get a good 30% grade this week, because even though he plays on his phone the whole time, you really want your points or whatever, you know. If that's you, then you want to get 5 through 10 done before we go over them. That way you can just give me the answer. Okay, the reason we have been avoiding them is because I assume you don't like factoring the way you haven't liked so many other things. As discussed, our last math workshops, we kept having a GCF. A lot of these don't have a GCF, so we have to do normal factoring. However, on 1, 2, and 3, the leading coefficient, meaning the number in front of the term that's squared, is what number?
1.
Eric, get a point. It's 1. So if the leading coefficient is 1, life is really easy. We're supposed to think of things that add to give us that middle term and multiply to give us that last term. So if you want to write it out, you can. So I'm needing 2 things that add to give me a -4 and 2 things that multiply to give me a -32. I need 2 numbers. Well, I get 4 and 8, but we got to be specific about the signs. She gets the point. -8, +4 gives you -4. -8 times 4 is -32. So my answer, because it's -8, is m minus 8. Since it's a +4, it's m plus 4. And those are my 2 factors. And that's what we're looking for. Now, can we do more with this? And we'll eventually get to that? Yes. But just for now, with these fun workshops, can we factor?
Is chapter 3 factoring?
No, chapter 3 is counting. But we can't. I mean, you still got the ACT, and even if you don't have the ACT, you might have a standardized test coming up for whatever college you're going to. We can't let go of the things you learned in Algebra 2 with Trig, or before that, or pre-cal, or whatever, just because you decided to take Discrete. We can't let it go. We don't want you to forget. Okay, on number 2, I need 2 things that multiply to give me -66, add to give me -5. Yes, dear?
-11 and 6.
-11, +6 gives you -5. -11 times +6 gives you -66. Perfect. So my factors are z minus 11, because it's -11. and z plus 6, since it's a positive 6. You can have a point for that, Craig. Are there any questions about number 2? Then let's do number 3. I'm needing two things that add to give me 13, multiply to give me 40. You can have your point. So it's 5 plus 8 is 13, 5 times 8 is 40, so it's going to be y plus 5 and y plus 8. Perfect. Obviously. Yeah, that was really good. Okay, number 4 is different. What's different about number 4? The leading coefficient is not a 1. There is a greatest common factor. And then just the duh part, how many terms do you count? 2. When we're factoring like we were just doing, we need 3. So if there's only 2, the best we can do is GCF. What GCF can I pull out? 12 what? You can have a point for that. And what are you left with? Okay, you can have a point for that. Okay, if we wanted to check Madeline, she's normally pretty genius, but everybody has their days. If we wanted to check her, what could we do to go back through this problem?
Distribute?
Yes, Tyler gets a point. We could distribute. And if we were going to check 1, 2, or 3, because we're questioning Zach or Craig or whoever answered those, what is the term we would use when we're distributing with those two binomial? Whoa. And you can get a point for that. Whoa. That was fast. Okay. Are there any questions about these factoring ones? If you are not, dying from the factoring ones, you know you could try 5 through 10. Again, we're going to go over those Thursday. Why are we not going over them tomorrow?
Because we're not going over them tomorrow.
I already told you. You've just forgotten. I am not going to be here tomorrow.
What are we doing tomorrow?
You're still doing math. Just because I'm not here doesn't mean that you're not going to do math.
Do we have a nice one or that mean one?
That mean one again. She's the one who accepted the job. So I wrote her a note and said that it was great if you were talking with your groups to make sure she was cool with the talking this time. Now, does that mean you need to go crazy? No, but you can talk to your group. My plan, which is why I'm questioning my whole sanity. So my plan was just to let you keep working through your book and not give you a random worksheet out of nowhere. That was my plan. However, we got to actually get it together today, because if you can't do 1 through 8 with me, how are you going to do the rest with her? Lord. Whew. But I will tell you one nice thing that I've not told you before. I have 2 answer books that have the answers to the back of the book. Now, it uses a lot of words. There are 1 or 2 in here who have seen the book. It uses a lot of words. So, a lot of words. So, 1, I'm going to know if you copied, because you would have never used that many words. And 2, I'm going to know if you copied, because eventually there's going to be a test. But if Bailey's group got super stuck on number 7, they just can't, they just don't know, I'm going to have those books on my desk. I'm going to write her a note and say, if Bailey's group is super stuck, allowed to look at key. So if Bailey's group gets stuck on a number because they just can't figure out that a truth table with all F's would be P and not P, then they can look at the key and feel like a blonde for half a minute. Is everyone cool with that? So just because I'm not here doesn't mean you can't get math accomplished and get unconfused when you get confused. Okay. So I keep making suggestions to you as we work through these activities. So chapter 2, there really wasn't no suggestion, just don't die by truth table. But chapter 1, there was a suggestion. You recall what the suggestion was when you're given some random scenario. What do I do?
Make this tree thing.
Craig can get a point. I like to make a tree diagram. Notice that learning target says I can use tree diagrams. So today, there's a cute little note thing on Sample Spaces. Tomorrow, there's going to be less than 5 minutes, people. Less than 5 minute video of me going over another cute thingy with truth tables. Every time I see you, I think truth tables. Of me going over tree diagrams. Just to remind you how they work and why they would be useful now. In fact, if I were you, so my goal is for you to get to number 8 today. I would put a star by number 8 right now in my textbook and put the word tree diagram next to it. Because honestly, number 8 and a lot of those from there on after, when they start getting complicated and you start mixing scoops and flavors and such, life gets easier with a tree diagram. Number 8. That's the one where for sure I would use a tree diagram. Okay. Before we go crazy with tree diagrams, we need to talk about ways to handle counting problems in general. Because what's going to happen is Bailey's going to rock at counting problems right now, and then I'm going to start doing something called permutations and combinations, and then she's going to get a random problem, and she's going to be like, I don't remember how to do the easy ones anymore. So I want to prevent that from happening, so hence our cute little notes. A sample space. So the very top says, a sample space can help you identify all the possible blanks of an experiment. What words should I put in that blank? Possibilities is one. I heard it. Possibilities, all the possible possibilities sounds silly, so all the possible outcomes is what I'm going to put. You do, and then Madeline, I'm going to let him have the point because you've done so many. Okay. So, he's right, possibilities make sense, but possible possibilities sounds kind of redundant, so we're going to say all the possible outcomes. So, and then they make you rewrite it, so I don't care if you do or not. The sample space is the collection of all possible, the collection of all possible outcomes in an experiment. And you wouldn't believe this, but you've already been listing all the possible outcomes of an experiment, haven't you, with your truth table. That's why we did all the T's and all the F's to have all the different possibilities. 2 T's, 1 T, 2 F's. We've already been doing this, which is terribly annoying. I would throw my paper too. A sample space can be used to find the probability of an event occurring. So there are some probabilities you're just supposed to know in life. Like there's 52 cards in a deck of cards. Pulling out one, it's a 1 in 52. Like that's just something you're supposed to know. When you flip a coin, there are 2 options, heads or tails. So you've got a 1 in 2, so you've got a 50% chance. Another thing you're just supposed to know. So if we're using a table to find the sample space for tossing 2 coins, I bet you already know all the options. But it could be, I could have 2 tails. I could have a tails and a heads. I could have a heads and a tails. I could have 2 heads. And yeah, this does make me think back to those terrible old truth tables. Because we're listing all the possible options. Okay, what is the probability of getting 2 tails? Okay, 2 tails. Both tails. Yeah, because it's this one, and there were 4 rows, so it's 1 out of 4. There are 4 possibilities, 2 T's, TH, HT, HH. There are 4 possibilities, and the possibility of being 2 tails was 1 of those 4, so 1 out of 4. Which, if we turn that into a percentage, which is what a lot of tests would probably do at this point, that's 25%. No big deal. Okay, the next question says, what is the probability of getting a heads and a tails? So, yeah, it's both these options, because it didn't say, like, tails had to be first or heads had to be first. So it's either option, as long as it's not tails, tails, heads, heads. So it's 1 in 2 or 50%. Either one's going to get you all your points. 2 out of 4, any of those are going to get you all your points. So, again, really we're just taking truth tables, and now we're applying some probability to it. Are there any questions on 5 or 6? Okay, flip to the back, and I think it's upside down. My bad. So, you know, of course, life's going to get more complicated, and if you've been reading the ice cream scenario in your book, it does get more complicated because there can be lots of different kinds of scoops, cones, etc. So, one way we can complicate things is by having a spinner with a couple different colors. So there are 1, 2, 3, 4, 5 different colors. Are any of the sections bigger than the other sections? No, they look all about the same. So the odds of getting 2 reds, that would be a red, red. Of getting a red and a yellow would be red, yellow. Red, green, red, green. Red, blue, red, blue. Red, purple. Yellow, red. Yellow, yellow. Yellow, green. Yellow, blue. Yellow, purple. Green, red. Green, yellow. Green, green. Green, blue. You're smart. You just read. Green, purple. Blue, red. You cannot keep up. I'm doing blue, and then that goes up to yellow. So BY for blue, and then the Y for yellow. Next, I'm going to do BG, blue, and then green. And then blue and blue, so BB. Blue and then purple. It's a good thing it's not in colors, it's words. So BP.
I think your favorite thing in life is to make others feel dumb.
Not really. Purple red. Purple yellow. Purple green. Purple blue. Purple purple. Okay. So I'll give you just a second to fill in your table. And now that we've filled this all in, so we've really listed all the options. So we spun our spinner twice, and we're looking at all the color combos of like 2 reds, a red and then a yellow, a red and then a green. Is anyone not done with their table? Yep, I see some. Okay, I'm give you a second. Okay, for the first one, it says, what is the probability of spinning 2 of the same color? So, it is, good job, and you can have a point. Red, red, yellow, yellow, green, green, blue, blue, purple, purple. Those are the 2 of the same color. How many do we have total in our table? We have 5 times 5, which is 25. And then we had 1, 2, 3, 4, 5 that were the doubles. 2 of the same color. So it was 5 out of 25, which does reduce to 1/5, which is 20%. How did you get 1/3? Red, red, yellow, yellow, green, green, blue, blue, purple, purple. That's 5. And then there were 25 total. Okay, does everyone understand why there was 25 total? And everyone understands why we're picking those 5, because they're the doubles. Okay, so then let's look at the next one. It says spinning a red and a blue. So we need RB or BR. I see red, blue. There's only 2, so 2 out of 25. Which is a really low percentage. Does anyone know what percent that would be?
10, 15.
Yeah, so it's 8%. Kayla, get a point. Okay, and then the last question says, what is the probability of spinning a green and a purple? So G and B. Green and purple. And then purple and green, where are you? There you are. And it is the same. Good, Tyler. You can have another point. Okay. Do you see how life was really easy to find the answers once we had given ourselves a good representation, like that table? That's my logic for why I like me a tree diagram, because then I've listed off all the options for myself, and I can just count up the ends. Like, oh, well, there were 3 that did this, and there were 10 that didn't, so it's a 3 out of 13 or whatever. It's tree tables or a table or something would make your life so much easier than you just trying to figure out everything all in your head all at the same time. Woo! Okay, are there any questions about this? Okay, then I need you and your people to finish the thing from yesterday, the 3.1 and 1 through 5 if you didn't already. And then you've got to do 1 through 8 on 3.1.1. But honestly, the more you get done, the better. You keep it for life. If that's what you want to choose to do, but I'll be asked this question later about it.
I'll just take a picture.
Can I look the rest of the past?
Our goal is to get all 16 done by the end of the day tomorrow. And that's really not as easy as it sounds. So you would like to get over number 8 today, to be honest. Over number 8. That would be the goal.
Over 8.
Over 8.
Sure.